Okay, doing something that I haven't done in quite a while here. We're gonna simplify some radicals. I want to look at this type of problem specifically where you kind of have a nested radical, one within the other. And what I wanted to do is go over a few different scenarios. I think I have 5 of these to do, like 5 different cases to try to cover some of the different variations of this kind of problem. So before we go ahead and get started on this first one, this is gonna be the simplest case. I wanna look at how we usually do these, or kind of the way I do them. There's some variations on this, but the thing to notice, if we have something like square root of a plus square root of b, and so I think for the most part we're going to be dealing with integers, positive integers for like a and b here. So if you square this, what's going to happen is you're going to get a plus b plus 2 times square root of ab. And then what I want to do is we want to kind of group this a plus b together here and then match it with what we have inside the radical here. Because if this thing is inside of a square root, then we can say for this is going to be, you would normally have absolute value, but this is clearly positive. So this is actually going to be just square root of a plus square root of b. So this is going to give us an easy way to simplify these, assuming it works out nice. It's going to be kind of a factoring problem, right? So not everything's going to factor with integers, but most of these are going to be set up that way where we can kind of match to this and then come up with our solution like this. So coming back to our problem, I like to kind of start here on what's inside this radical. We already have our 2 in front, so I'm not going to worry about that. That's good. Then trying to write this 48 as something like a times b. Now with 48, the factoring of that, there's a lot of different ways you could do it, right? There's, like, you could do this as 1 times 48, 2 times 24, 3 times 16, but we want something where our a plus b is going to add up to 14. So you can kind of mess around with the different options on this, but what's going to work is if we factor this, if we write 48 as 6 times 8, then just putting it in this form right here, we could write this as square root of 8 plus square root of 6 squared. And so if you're not too familiar with these, just multiply this out and see what happens, because you're going to get this right here. You're going to get that a plus b, you're going to get 8 plus 6 is going to give the 14. And then for the middle terms, you're going to get this 2 times the square root of 48. But then here we can kind of cancel the square root with the square. And so for our solution to this, we have square root of 8 plus square root of 6. I can simplify it a little bit if you want. You could do square root of 8, you can write this as 2 square root of 2 plus square root of 6, and that's going to be our simplification for this first one. Next, for example number 2, we've got something a little different. We've got square root of 8 plus square root of 28. And the reason this is a little different is now we don't have this 2 in our formula, right? So what I like to do is try to create that, and here we have a factor of 4 in here. So it could be more complicated if we didn't have a factor, if it didn't divide by 4. But 28 we can write as 4 times 7. And then we can take that 4 out, and we can write this as 8 plus 2 times square root of 7. And then here we have it in this form now. We put our 2 here. 7's prime, so there's only one way to do this, right? This is going to be 7 times 1. So then looking at this, we can write this as square root of 7 plus square root of 1 squared. Cancel the square with the square root. Don't worry about absolute value. And our solution to this is just going to be square root of 7. This is just 1, so we'll have square root of 7 plus 1. Moving on to number 3, we've got the square root of 21 plus 6 square root of 10. And here, now we've got something outside the radical, but it's not a 2. Doing the same kind of thing, we want to get it in this form for 6. Of course, I can write that as 2 times 3. And then I can bring the 3, or I multiply the 3 inside the radical here. So when we do that, let's see what's going to happen. We have 21 here. Now we just have our 2 in front. When we multiply it inside the radical, we're going to have to square it, so it's going to become a 9. 9 times 10, you know what I like to do here is maybe let's just leave it broken up for now for our 90. The reason I don't put it together is we're going to break it up here in a second, so I might as well leave it separated. Where it really works nice is when you can just leave it, and then, like, if 9 plus 10 was 21, but it's not, it's 19, so we can't really use it the way it is here. The way I want to factor 90 instead is going to be if we use 6 times 15, because then 6 plus 15 is going to be 21. So doing it that way, using this, we have square root of square root 15 plus square root of 6. This is all squared. Get rid of this and this, and what we're left with for our solution on this is just going to be square root of 15 plus square root of 6. Okay, number 4. Now I threw this one in because I forgot. I wanted to get something in here with a minus sign. This is really going to work the same way. regardless if you have this as plus or minus. The only thing is if you use a minus sign, you're going to want the a to be greater than b, just so that you're not, the reason for this is if you had b greater than a, then you've got like a negative value inside the radical. We're not dealing with complex numbers here, so we want to keep this pretty simple with this. Now that works here, of course, 49 is greater than 48. Then the other thing is, in our form here, there's no radical in this part right here. So, but the square root of 49 is a perfect square, so we can actually just write this as a 7 for the square root of 49 minus square root of 48. And then doing the same thing we did before, we want to create this 2. So here, 48, we can write that as 4 times 12. And then, so rewriting this, we have 7, square root of 4 is going to be our 2, and then we're left with square root of 12. But then here for 12, I can write that as 4 times 3. So putting it in this form, what I want to do, we want, again, our a value to be greater than b, so we want, I think I've been mixing two different ideas because yes, this needs to be greater than this, but it also is true over here when we have a negative sign. So we want to put the 4 first anyway. So for this form here, we want this as square root of 4 minus square root of 3. I guess you could do it the other way here, because then when you cancel this and you do leave the absolute value, then you're going to need to rearrange it in order for this to be positive. But anyway, the way we have it here, this is positive square root of 4 minus square root of 3. So then square root of 4, of course, is 2 minus square root of 3, and that's going to be our solution for number 4. Now this one actually looks a lot like the one we just did with a plus sign instead of a minus sign, because you'll notice if we put this as a square root, we can write this 14 is the square root of 196. But that's not really the issue on here. I think here the thing we need to deal with is to get it in this form, we want to get a 2 in here. And now in this case, 195 is not divisible by 4. So we can't just pull a 4 out. So we need to create it. What I can do is multiply everything by 2. So we multiply 14 times 2, we get 28. Multiply this by 2, we have 2 square root 195. But I don't want to change it, so we need to divide by 2, but we need to do it within the radical, so that will be a square root of 2 in the denominator. And what we do is we leave the square root of 2, but then we use this formula here on the numerator part, and what we can do is factor 195. That's going to be something, let's see, like 5 times 40 is 200, so 5 times 39 is 195. I can break this up further, get the prime factorization like this. But now if I group it a different way, 5 times 3 is 15 times 13, but then 15 plus 13 gives me 28. So coming to our formula, this here is going to be our a value, this is going to be our b. We can write the numerator as square root of 15 plus square root 13, all squared over square root of 2. Cancel this with this, and then putting it together, you kind of write this a couple different ways. Actually, let's separate it out. So I'll write it as square root 15 over 2, just dividing in the square root of 2 here, plus square root 13 over 2, and that's going to be number 5. Now here's the last one, problem number 6. I did lie originally because I threw in an extra problem, so now we're doing 6 instead of 5. But anyway, here the issue is we've got a 3 in front, and we want a 2. And it's not like that case earlier, I think we had a 6, where we could leave a 2 and bring a 3 inside, but here there's nothing. 3 is obviously odd, there's no factor of 2 in here. So what I can do is we can bring that back into the radical. So rewriting it, we have 11 minus squaring 3, we have 9 in here. 9 times 13 is 117. Maybe I'll leave it, we'll just leave it like this for now. We'll leave it 9 times 13, but this is also 117. But now the problem again is we're missing the 2 in front, so I can multiply into here, multiply in, that's kind of confusing looking. So 2 times 11 is going to be 22, multiplying a 2 there. And then in order that we're not changing it, we have a square root of 2 in the denominator. So let me just rewrite this to be clear what's happening. So this is going to be 22 minus 2 times, and we'll leave it as 9 times 13. So coming back here, if we say, we'll say 13 is our A and 9 is going to be our B. Then a plus b, 9 plus 13, that's going to be here. That's going to be 22. So this is just going to work the way we have it. So I can rewrite this square root of 2 here. This is going to be square root. Then our a plus b, we're going to have, again, I'll write the larger number first so we don't have to worry about the absolute value. So we'll have square root of 13 minus square root of 9, which we'll simplify in a second. This is all squared. Cancel this with this, and we have here square root of 13, but now let's simplify minus square root of 9. That's going to be just minus 3 over square root of 2, and that's it. Okay, so there you go. Quick run through on the radical simplification. So one notice, the thing I didn't cover is the case when it doesn't work out nicely, when you don't have a nice factorization with integers. Then for those, you probably need a calculator, because there is a formula you can do a simplification on it, but it's like, if this doesn't work out nice, the simplification you do with the formula is more of a mess than what you started with, so it doesn't really serve any purpose. So what you'll notice is when you see these on YouTube, they're usually carefully arranged so that they work this way, and they have integer solutions, or something like this. This obviously is not an integer, but where it works out, it's still pretty clean. Anyway, there you have it. Thanks everyone for watching. Have a good day.